All right. So here's the concept of inverse functions. Okay. Okay. To find the inverse, you switch the x and the y. Okay. Here's a concept. The domain and range switch because you're switching the x and y, right? So it makes sense that the domain and range would switch. Now this is kind of a hard one, and even after I do an example, it takes a couple examples to kind of get this one. To graph the inverse, you reflect the original graph over the line y equals x. Now, do you guys know what the y equals x line is? Well, think about it for a sec. Y equals x. I'm going to go down here because there's a graph here. If x is 1, what's y? If x is 2, what's y? 3, 3, 4, 4, 5, 5. Same with negatives, right? If x is negative 1, y is negative 1. Negative 2, negative 2. So we end up, the y equals x line is a angle line that goes from one point of the graph to the other. That's our y equals x line. And if you go on in mathematics, this line becomes kind of important. Okay? So that's a y equals x line. All right, number 4, the inverse is a function. Remember what a function is, right? Passes vertical line test. No repeating x's. Don't start, you delinquents.
What do I do?
I see the look in your face. I just see
I
it.
didn't do anything.
I know, but I see it. It's coming.
Thomas is looking at me.
Yeah, that too. I mean, it's not just you; it's him too. I see it in his face
But
too.
it's mostly him to me.
Well, I don't know. I don't know. I see it in his face, but I see it in your whole body actions.
My body actions.
Yeah.
Oh, okay.
Yep. Thank you. I'm glad I recorded that.
Got me tonight.
Uh, number, all right. So, number 4, the inverse is a function if the original passes the horizontal line test. And again, we'll get to that. And number 5, we're not going to deal with a lot of number 5. In fact, I don't think we'll deal with it at all. The compositions, the f of g of x and the g of f of x, both given as a result of x. We're not going to work on number 5, but you should know number 5. And I believe the way I had to do it is I had to multiply these two together, and if it were came out to -1 or something, then they were inverses. So there's actually a sixth one. So let's do the first one. Okay. Um, to find the inverse, now we know this is a function, right? This chart here, because there's no repeating x's, right? So we know that this is a function. To find the inverse's domain and range, we're just going to switch the x and the y. So here's my y and my original function becomes the x's in my inverse function. So this is my inverse function. Maybe, we don't know because we didn't really check to see if it's, this is a function or the horizontal. Anyway, this is my inverse domain. So I'm going to have 4, 2, 0, -2, and -4. And I know this is a function because I did check this one. So this is my original function. Okay, so my original function here, my x values become my y values in the inverse. So I have -2, -1, 0, 1, and 2. So I know that this is a function because I have no repeating x's. Is my inverse function also a function, or my inverse graph a function? Yes, because I don't have any repeating x's. So this is indeed a function. Okay. So we need to find the inverses on numbers 2 and 3. And this time we're given an equation, right? And to find the inverse, we're going to use number 1. To find the inverse, you switch the x and the y, right? So I'm going to switch the x and the y. So here I have x equals 2y minus 4. So to find the inverse, what do you think I'm going to do? I'm going to solve for y. Okay. So I'm going to add 4 to both sides. I get x plus 4 equals 2y.
You divide 2y.
Right. I divide by the coefficient 2. Now,
Tom just looked at me.
stop it, Thomas. Stop looking at
Oh,
it.
he knows.
Close your eyes, and stop looking. There, does that help?
Yes, thank
Okay, all right. All right, now you could divide each one of these terms by 2, and that's what I did with my last class. But you know, since we're just finding the inverse, you could just draw a line and divide the whole thing by 2. So my answer here is x plus 4 over 2 equals y inverse. Now, to distinguish that this is an inverse of this, we're going to put a little -1 there. So that's the inverse notation.
Mr. Dean,
Yes, ma'am.
is there an answer key for the worksheet? I
Uh,
just want to know if I did the first problem right.
Probably, but I have to look for it. It took me a while to find them.
Okay.
I-
Because the answers aren't on the back like they usually
I know,
are.
I know. I had to move all my stuff, and I printed them off. I couldn't find them, and long story. But anyway, I'm sure I do. I got to find it though. Okay.
Okay.
All right, number 3. So I have to find the inverse. First thing I'm going to do, switch the y and the x. So x equals -2/3 x plus, or y, sorry, plus 6. Subtract the 6. Good. So I get x minus 6 equals -2/3 y. What's the easiest way to get rid of a fractional coefficient? Yeah, multiply by its reciprocal. Very good. Now, I don't know. Should I make you guys multiply this out?
How much do you like it?
Not very much,
Besides me.
especially
Stop.
the two stooges over there.
You say you don't like us that much?
So here's my y inverse, right? We should distribute that. -3/2 x, right? And what's negative 3/2 times negative 6?
Positive.
It is a positive. Anybody know? I'm going to guess and say 9. What do you think? Did I guess right? It's going to be a positive. Yeah, so, very good. That's my answer. You guys remember how to multiply fractions in your calculators? Huh? 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 Do you? Do you? You guys do not seem all that confident. So I'm going to take negative
Someone just looked at
3/2
How would you know? You went to second
times
cracking my back.
negative
Turned
6
around.
equals positive 9.
Wait, I got a negative.
I'll probably do that.
Negative times a negative is going to be a positive.
Right.
All right, now let's take a gander at this here horizontal line test thing. Okay. Now, so here's the concept. The inverse is a function if the original passes the horizontal line test. Okay. If the original, and they should not, with the inverse of the functions graph, this is wrong, okay, because this is not a function. This graph is not a function, is it?
Fails BT.
Yeah, it fails the vertical line test. So that's kind of a typo here. Okay. We should say of the graphs below. Okay, these are just graphs because we haven't determined if they're functions or not. Anyway, so here's my original graph. Okay, here's my horizontal line test. Okay. Does if I take this horizontal line test and go through this graph, does it intersect at exactly 1 point throughout? Think about it. Let's do some test points. Here crosses at 1 point. Here crosses at 1 point. Here crosses at 1 point. 1 point. 1 point. 1 point. So it indeed does pass the horizontal line test, doesn't it? So therefore, okay, so we know that it passes the original graph. Passes the horizontal line test. Therefore, and we have a symbol for therefore in math. Therefore, 3 dots in a triangle. Therefore, its inverse. I didn't need apostrophe there. Its inverse is a function. Does that make sense? Does it make sense?
Yeah.
Wonderful. Now I'm going to attempt to draw the inverse. Let's see. Here. I'm not going to be able to do it, so I'll just sketch it. So it reflects, this is going to reflect about this. It's going to look something like this. Okay. This is going to reflect about this. If I were to switch the domain and range, I would get a parabola opening upwards. And that indeed does pass the vertical line test. So we know that the inverse is a function. Okay? All right, let's do another one. Number 7. Here's my original graph. Looks like a frequency sound wave, maybe a sine graph or something. Does it pass the horizontal line test?
Nope.
No. No, no way, not even close. So it fails. Let's see how can we write this? Original fails horizontal line test. Therefore, its inverse
It's not function.
not a function. Good. So clearing up a little bit, making more sense. Okay, number 8. Here's my original graph. Looks like the cubic function, some kind of a cubic function, right? Does it pass the horizontal line test? Yes, it does. Okay. So, original passes horizontal line test. Therefore, inverse is a function. Pretty cool, huh? Okay, I think we got a couple more examples in the back.
None of the examples
If I have, excuse me, if I have
oh yeah.
function notation, replace it with a y. Okay, and then start finding your inverse. Switch the y and the x. So I have x equals 5y minus 2. And then solve for y. So I'm going to add 2. So I have x plus 2 equal 5y. Divide by 5. And I get x plus 2 divided by 5 equals my y inverse. Now, if you go on in math, I think pre-calc is going to want you to put it back into function notation. So x plus 2 divided by 5 equals the g of x with the minus 1 to denote that it's an inverse. Okay. I'm okay either one of these. Number 10, going to replace the f of x with y and switch the x and the y. Okay. So I got y equals 4. Oh, jeez, I did it again. X equals 4 over y. Multiply both sides by. We could multiply by 4. It's not going to get us too much. It's just going to be 16 over y equals 4x, right? We have to multiply by the denominator, right? Because the denominators cancel, I get my 4. Here I get y times x, right? I want y by itself, so I'm going to divide by x. So y inverse equals 4 over x. Notice what happened. It's the same thing, right? The original function, the f of x, equals 4 over x, or y equals 4 over x, is the same as y inverse. The inverse and the original function are the same. And if you want to rewrite this as y, not y. Let's see, this is the f of x inverse, right? If you go on in mathematics, they're going to want you to write it like this. Otherwise, for this course, this is fine. Do you guys want to verbally explain how the horizontal line steps works? Because, every time I do that verbally, it seems to confuse students. I think visually it's easier to see if you do it visually. So I'm not going to go through those wordiness stuff, okay? You guys got any questions?